Hey folks, hopefully you have a good understanding of what cellular respiration and photosynthesis is from the notes from yesterday. Today we're going to be going a little bit deeper into what the actual carbon cycle is. So looking at how different organisms interact to keep carbon cycling throughout our environment. You will notice that in your PDFs you have these papers that talk about the carbon cycle in a lot of detail. It talks about where carbon came from, it talks about what carbon does, why it's so important, and we got some analysis questions at the end. I do want you to take a read through those because it will give you a lot of fine details, but I want to just do a quick diagram to kind of summarize what's going on. So CO2, carbon dioxide. Carbon dioxide is a major component of our atmosphere. So let's start there. We have CO2 in the atmosphere. Now that CO2 isn't necessarily useful for a lot of things, but one of the organisms that really takes advantage of CO2 is our plants. You guys remembered yesterday through photosynthesis. Let's see, photosynthesis. The CO2 is taken from the atmosphere, it goes through a chemical reaction of carbon dioxide plus water, making carbohydrates and oxygen. So through photosynthesis, we end up making the compound carbohydrates, which is C6H12O6. And those are going to be stored in our plants. Now, what happens with that carbohydrate that's found in the plants? Well, if the plant uses it, it goes through a process of cellular respiration, and it goes back into the atmosphere as CO2. And you can see we have a little tiny carbon cycle here. Carbon dioxide and water go through the process of photosynthesis to make carbohydrates and oxygen. That carbohydrate is then used by the plant through the process of cellular respiration to release CO2 back up into the atmosphere. Water is also released at this time. But that's not very useful for us as consumers. So let's say this plant stored this carbohydrate. Now what's going to happen is that carbohydrate is going to be consumed by a primary consumer. So it's still going to be a carbohydrate, C6H12O6, and that's going to be found in a primary consumer. Fantastic. Now, if that primary consumer uses that carbohydrate, it's going to be returned to the atmosphere through our process of cellular respiration. We all know that food chains don't always end at the primary consumers though, and you can see how we would go on and on. Let's add a secondary consumer. If the primary consumer didn't use that carbohydrate, it would have been stored in its body. That carbohydrate, when the primary consumer is consumed, goes into the secondary consumer. So it's still a carbohydrate. And now it's in a secondary consumer. Same as before. If that secondary consumer uses that carbohydrate, it's going to go through cellular respiration and return it to the atmosphere. Let's say for whatever reason this secondary consumer is the top consumer in that food chain. Another option of what might happen here is if this organism or any of these organisms, if they die and are not consumed by consumers, it might go to a decomposer, which then again would go through the process of cellular respiration and release CO2 into the atmosphere. So we can see how there's a lot of little cycles in here, but we follow the carbon through each consumer. Goes to a plant, goes to the primary consumer, goes to the secondary consumer, and can return to the atmosphere. So there's a bunch of little mini cycles in here. Now, before humans came along, we had this nice little cycle. About as much CO2 was removed from the atmosphere through photosynthesis as was returned back to the atmosphere through cellular respiration. Now, if you follow the news at all, you know that we keep on talking about how we are releasing greenhouse gases into the atmosphere. Now, how do we do that? If the CO2 and the carbon has always just been rotating around and around and around, where did this extra carbon dioxide come from? Well, if you've read your notes already, you might have heard about it. It's something we call a carbon sink. You may have heard of fossil fuels before, oil. It all came from organic matter like millions of years ago. And for the longest time, it was stored in a carbon sink. So when it was underground or stored away in this carbon sink, it was taken out of the cycle. But now, from that carbon sink, we are bringing it to our factories, or to our cars, or to many other things. Did I spell factories right? Probably not, but that's okay. Now what these factories are doing is they are releasing all of this carbon, which was in a carbon sink, and it is going back into our atmosphere. Ooh, there's a drawing on the table. And it's coming back into our atmosphere, and it's disrupting our cycle. So now we have more CO2 being added to the atmosphere than we can take out through photosynthesis. Now the reason this is a bad thing, if I can find myself a blank piece of paper to keep drawing, is our atmosphere and our world, the CO2 kind of acts as a blanket. So imagine we have our world, our Earth, nice little round Earth. When the sun's rays come down, we're gonna have orange sun, it comes down, some of it is reflected off, some of it warms the Earth, and some of it actually bounces back and forth inside of our atmosphere. So the CO2 kind of acts like a little blanket, and it holds in some of the sun's rays so it can warm us up. So it bounces off a little bit, eventually it's released. But when we have extra CO2 in our atmosphere, it kind of makes this blanket a little thicker. And it makes it so that it can hold in more of the sun's radiation. And when it's holding in more of the sun's radiation, we have less that's being released and more of it bouncing back and forth. And it's like when you go to bed. If you have on one blanket, you'll be warm, you'll be good, you'll be comfortable. If you put on 2 or 3 blankets, you're gonna overheat. And that's what's happening when we add the extra CO2 into the atmosphere, is we're layering on extra blankets in our atmosphere, and it's acting like a greenhouse. So a greenhouse is one of those places where you grow flowers and plants in the springtime. It just keeps it extra hot, which isn't great for the rest of our world processes that kind of rely on a certain amount of heat. Okay, perfect, thank you guys. Make sure you complete your questions at the end of this PDF. Thanks, folks.